So, whenever you're ready, I can start. My research with Kelly Hobart is the combustion properties of reclaimed used engine lubricating oil blended with salmon fish oil and woody pyrolysis oil. And that's a mouthful, so I'll break it down. Combustion properties can be either fuel properties or emission properties. Reclaimed used engine lubricating oil is reprocessed used motor oil from your car, usually. Could be from trucks or from industry, but engine lubricating oil. Salmon fish oil is a bio oil made from reprocessed fish waste. And woody pyrolysis oil is another bio oil made from the pyrolysis of wood residues. And I'll go over the fuels in a second. But today I will talk about the problem that I encountered in the research, the initial problem statement, we could say, the background of the fuels, the objectives of my research, the experimental methodology I used, and the results and discussion, and finally conclusion. So, there is no published research on the combustion of used engine lubricating oil and biofuel blends. Used engine lubricating oil is commonly recycled as a fuel. However, it creates pollution often when there's no pollution guards at the flue stack. Bio-oils are an attractive alternative to fuels because they're sustainable and they replace petroleum sources. However, there can be some difficulties with combustion, especially with pyrolysis oil, which we'll go into later. So in my research, used engine lubricating oil, I got it from the Pit Crew drive-thru, which is a local business here, and it generates a lot of used engine oil, 120,000 liters a year. And what they do, they reclaim it on site into a low-grade fuel. And that fuel is used for space heating in a furnace. Bio-oils. There are two bio-oils that Kelly Hobart studies here at MUN. Of the two, there's salmon fish oil extracted from fish meal processing waste, which is a process that's commonly found in Newfoundland that takes the waste that they produce is guts and viscera and heads, and so what you can create is a lipid-based bio-oil. And the other bio-oil is pyrolysis oil from the pyrolysis of woody biomass, which is mostly forestry residue, and it is the process described down here is the woody biomass in an inert atmosphere, so that's without oxygen, in the presence of a large amount of heat ranging from 3 to 800. It creates a biochar, a carbon-based char, a bio-oil, and a biogas. And this bio-oil that's produced is generally organic acid and lignin-based. Lignin is a property, or is a chemical in oil, in wood products that ends up in the oil. So with these three different oils, my objective is to investigate the application of reclaimed oil from the Pit Crew and the bio-oil blends as fuel. So first, I want to determine the promising blends for combustion. So I take different blends of reclaimed oil and salmon oil, and reclaimed oil and pyrolysis oil. I determine their miscibility as well as their chemical, physical, and thermal properties. And then once I found promising blends, I combusted them in a custom-built pilot-scale furnace, which I'll explain to you soon. So, the experimental methodology, I went with, after blending the different fuels, I discovered their physical properties, which is density and viscosity, their chemical properties, which is water content and elemental analysis, which CHNO SO is a carbon, hydrogen, nitrogen, sulfur, and oxygen. Their thermal properties, which is heating value or calorific value, a flash point, and TGA, which stands for thermogravimetric analysis, which is the decomposition of that fuel versus temperature. I won't go into all of these in detail, but we'll review them throughout the lecture or the seminar. The results of those experiments, which were the blending and the characterization of those blends, were that reclaimed oil and fish oil blends are promising for combustion. And pyrolysis oil and reclaimed oil blends have more of a difficulty because of their miscibility. Here we see that reclaimed oil is mostly made up of hydrocarbons from lubricating oil. Fish oil is mostly made up of lipids in the form of free fatty acids and derivatives. Pyrolysis oil is mostly made up of organic acids, water, and lignin, which creates this. Pyrolysis oil is a mixture of polar and non-polar chemicals, whereas fish oil and reclaimed oil are mostly non-polar, which is the main reason why fish oil and reclaimed oil are miscible, which means they mix and there's no phase separation, whereas pyrolysis oil and reclaimed oil are immiscible. They create a phase separation, which makes it difficult for combustion and storage because they won't stay together, essentially. As well, there's other properties. You can see that fish oil, reclaimed oil have a similar density, whereas pyrolysis oil has one that's greater than water and much different. As well as viscosity. These are similar, and pyrolysis oil is further away. Water content is one of the main reasons or main sources of the polar part of pyrolysis oil, and you can tell that fish oil and reclaimed oil have very low water content, and in turn that affects the heating value. So reclaimed oil has a relatively high heating value, which is very similar to diesel fuel. Fish oil is close to that, and pyrolysis oil is very low due to its composition. So, after choosing the reclaimed oil and fish oil as promising blends, the next step was to combust them in the furnace. This furnace was built here at MUN. It has a multi-fuel burner, which means it can burn many different types of fuels, thick ones, and it has and our goal was to burn reclaimed oil by itself, fish oil by itself, a 50% blend of reclaimed oil and fish oil, and also burn diesel and compare the results of each of these three fuels to diesel. And the results came from emissions. So we looked at the exhaust gas concentration with a flue gas analyzer, which is a common tool used for flue gas analysis, as well as a gas chromatography. We captured a sample of the gas and put it through a GC, which, for those who don't know, it ionizes the gas, or some of the, not this one actually, it heats up the gas, passes it through a long tube, and different compositions in the gas elute at different temperatures, and you can almost separate and see how much of one substance is in the gas. So the results of the furnace experiments, there was a lot of data, and I'll try to filter it down into four basic points. The first one is adding fish oil to reclaimed oil decreases sulfur oxides and particulate matter emissions. And it's because sulfur oxides depend on fuel-bound sulfur. And as it happens, fish oil is very low in fuel-bound sulfur compared to reclaimed oil. And particulate matter also depends on the fuel property, which is ash content. And you can tell here fish oil also has a lower ash content than reclaimed oil. The second main point is adding fish oil increases CO2 emissions. And I initially found this out with a stoichiometric calculation based on the elemental analysis, the carbon, hydrogen, nitrogen, oxygen, and it showed that fish oil produces a higher concentration of CO2, mostly because there's higher oxygen in fish oil than there is in reclaimed oil and diesel. And the second reason why is because the GC results showed a higher fish oil peak than for the 50% blend, while there was some unforeseen issues of co-elution in these two results, you can extrapolate that adding fish oil does create more CO2 emissions. The third point is adding fish oil to reclaimed oil increases nitrogen oxides or nitrous oxides emissions. And it's because nitrous oxides are dependent on nitrogen content. But here, fish oil has low nitrogen content, so that doesn't make sense. But after further research, there's a more prominent source of nitrous oxide in combustion, and it's more dependent on flame temperature than it is on nitrogen content. And you can see that the calculated adiabatic flame temperature is much lower for reclaimed oil and diesel oil, and as well as the measured exhaust gas temperatures of the furnace itself, the fish oil was also lower than reclaimed and diesel. This leads to a conclusion which is similar to other research that adding fish oil increases nitrous oxide emissions. The fourth conclusion we can draw from the furnace results are that methane, dinitrogen oxides, nitrous oxide, N2O, and carbon monoxide are mostly dependent on burner configuration. So, which essentially that means that if you have a complete combustion, if there's enough oxygen compared to the amount of fuel that's going through the burner, the oxygen will react with CO and turn that into CO2, and the oxygen will react to this and create O2 and N2, and this CH4 will combust in a healthy combustion environment. But if you don't have the exact right burner settings, then you will get more of these emissions. However, there are some studies that show that CO emissions are lower for fish oil compared to diesel. And these studies are studies that take one burner and they don't change the fuel settings, and they burn diesel, and then they burn fish oil. And since fish oil has higher oxygen content, then more CO will turn into CO2 due to the nature of the fish oil. So in conclusion, reclaimed oil and pyrolysis oil are immiscible, and while pyrolysis oil has some good thermal and flow properties for combustion, blending it with reclaimed oil was essentially impossible unless you added something else which could be done in further research. The reclaimed oil and fish oil blends show promising combustion characteristics because of their miscibility, their ignition and steady state combustion. They combusted well and rather easily in the furnace. And adding fish oil to reclaimed oil decreases sulfur oxides, particulate matter, and carbon monoxide. At the same time, adding fish oil increases nitrous oxides and carbon dioxide. Are there any questions?
I read the thesis, so I expect questions from
So I have a question.
Yes.
I'm curious. If I was to burn a blend of fish oil and fuel oil in the furnace of my house, would my house smell like fish?
Oh yes, yes it would.
So that it smells.
Yeah, it does smell. Although I personally noticed it didn't smell as much as I thought.
Okay.
I was running the furnace outside, which makes a difference. As well, the 50% blend, I almost didn't smell it from the emissions.
And another question which I had was, I can't help but think, like, when I make a salad, and I pour olive oil
Yeah.
and vinegar, and there's phase separation.
Yeah.
Then if I add Dijon mustard and mix it up,
Yeah.
it stays together, so it's like an emulsifier. So what happens if you add an emulsifier to the pyrolysis oil and the...
It's a very good question. And yeah, there are researches in that area. Actually, Kelly's other student, Anka, has done research on this. She's looked at blending pyrolysis oil with petroleum-based fuels in the presence of methanol and ethanol, and they act in some concentrations as emulsifiers.
And thanks, by the way, for dumbing down the presentation to my level. So I would be able to ask these questions if I didn't understand their presentations. So that's another comment. Thanks.
Yeah. So the question I had thinking is, so you can burn mix of waste oil and fish oil in a conventional burner, like in our case a fuel number 5 burner.
Yeah, they're called multi-fuel.
In other words, you still need to preheat the blend, the liquid, before